Hello, geometry students. In this lesson, a continuation of triangle congruence proofs. Methods for proving triangles congruent, various combinations of sides and angles. The ones that don't work, 3 angles, and of course, an angle and 2 sides. Those are not methods for proving triangles are congruent. So look at this first problem. Ultimately, they're going to give me some information, AE bisects BD, parallel lines, and then I'm going to use that to prove that these triangles are congruent. Now, on these types of proofs, they're giving me a lot of steps already, and because of that, I have to be careful. I know that they're shooting for angle, side, angle on this one, so keep that in mind. AE bisects BD, that's given. Parallel lines, that's given. AB segment, parallel to DE segment. Among the things they have told me already, I know that AE bisects, so I know that this is congruent to that. I also see that I have a pair of vertical angles. So I'm going to go ahead and put that in the record. BC is congruent to BD. BC congruent to DC. That's because of the definition of bisect. They told me it bisected. That's the definition of bisect. And they're also saying that the angle ACB DCE, so these are the vertical angles. They're both centered around C. So those are congruent because of vertical angles. Now this last one's kind of tricky because if you think about it, they're telling me they've got perpendicular lines cut by a transversal. Well, when I saw it, I saw this one. And I knew that this was congruent to that. So I said angle A is congruent to angle E. That's true. But they're specifically saying they want angle, side, angle on this one. So I have to have the angle that's at the other end of the side. So I have to prove that B is congruent to D, which I do the same way. I just use a different transversal. So it's this transversal, and I'm looking at this angle and this angle. It's still alternate interior. It's just that they specifically wanted angle B is congruent to angle D. However, it's also true that angle A is congruent to angle E. Perfectly legitimate method for proving it. The triangles are congruent. By angle, side, angle, the other method would have been angle, angle, side. They're both legitimate. How about this next one? I'm trying to prove triangles congruent. On the face of it, it looks like I've got a couple of sides. So maybe if I try for the third side, maybe that would be good, or maybe I have some angles here. If I had angle, I'd have angle, side, side. That's no good. Well, they're telling me that Q is the midpoint. That means I know that this is congruent to that because that's the definition of midpoint. So that's where I'm headed, side, side, side. All right, first piece of information. Q is midpoint. Q. Etc. And they're also telling me that PS is congruent to QT. And they're also telling me that QS is congruent to RT. Oh, I take that back. That's actually what they're looking for in the next line. I could have put that all in one line, but they're actually asking for another given line. All right, well, they tell me that Q is the midpoint, so I now know that PQ is congruent to RQ, PQ. Here's what I found. PQ is congruent to RQ. That's the definition of midpoint. So these two triangles are congruent by the most basic one, side, side, side. Done. Look at the next one. It almost looks like I've got another side, side, side here. I believe I probably am. This is almost identical to the last one. So I'm going to probably try and prove that MN is congruent to NO. But it may seem obvious, but you have to put all this information in the record to prove it. Otherwise, you won't prove your case. LN is congruent to OP. That was given. LN is congruent to PN. LN, PN, that's also given. And they tell me that N is the midpoint. That means I know that this is congruent to that. MN, I have to use 3 hash marks because one is already used. That's going to be side, side, side. So how do I know that MN segment is congruent to ON segment? Because that's the definition of midpoint. And finally, I have proven these triangles congruent. LMN, PON. So that's 2 in a row, identical. Maybe this one will be different. Will it? Looks very similar. All right, prove the triangle's congruent. I have some sides and I have some angles. Somehow or another, I need to get another angle or another side. So what are they telling me? They're telling me that C is the midpoint. That means I know that this is congruent to that. So this is probably going to be side, angle, side. It is. All right, let's put some stuff in the information. Angle B, angle E, that was given. AB congruent to DE, that's on the diagram, that's also given. And then, of course, the third thing that they gave me was that C is the midpoint. What does that mean? That means that BC is congruent to EC because that's the definition of midpoint. So BC segment is congruent to EC segment. The triangles are congruent because of side, angle, side, side, angle, side. That one's done. How about this one? Looks like we're probably going to have some vertical angles in this one. They're telling me QT bisects SP. That means I know that this is congruent to that. QT bisects the other one. They also tell me that SP, the one I just bisected, bisects the other one. So this is congruent to that. And because I know angle R is congruent to itself, this is probably going to be side, angle, side. I've got vertical angles here. They didn't tell me any other information, so I think that's where I'm going. All right, start with QT bisects. That's given. The other one that they told me was SP bisects QT. That is also given. QR is congruent to TR. QR congruent to TR. That's the orange. Definition of bisect. PR is congruent to SR. That's the yellow. That's also definition of bisect. And then, of course, what I was saying, R is congruent to R. It's not sufficient to say R, though. You must use 3 letters. So QRP is congruent to TRS, Teacher Retirement System. And that's because of side, angle, side. Side, angle, side. Look at it. Side, angle, side. Side, angle, side. And that one's done.